My dad was a NASA engineer, so he brought us a tour at Johnson Space Center. And they asked my brother what he wanted to be, and he said an astronaut. And then they asked me what I wanted to be, and I said an astronaut. And they said, what? Girls can't be astronauts. You know, in their mind, they were right. They just didn't realize that the future would be different.
It's hard when you're young, when you're a teenager. There's a lot of peer pressure to conform.
There is a certain stigmatism to being a woman in technology. It doesn't seem to be something that you do.
I didn't want to be stuck at my desk, programming on a computer, 8-10 hours a day, every day for the rest of my life. It's just not how I saw myself. But so much of it is also collaborating with other people and brainstorming and problem solving.
It's working as a team. It's building things together.
It always feels like play. It doesn't feel like work.
I'm always surprised that there are not more women going into tech, because I think it's growing and there are just lots of opportunities.
There is no roadblocks, being a woman in technology.
There were a lot of naysayers. They're like, don't do that. You're never going to be successful. And so one of the things I learned very quickly is you've got to stay focused and you just have to believe in yourself and just make it happen.
I come into work every day excited about the challenges and the possibilities.
It's incredibly satisfying to know that you're doing something that has that type of impact and that type of reach.
You really feel like you're doing something that's helpful and that's making a difference.
I'm able to create something that most universities in the world use. How impactful is that?
5 million businesses use the products that I've been working on.
Every time you type in a query, you're using my code, and that means that I'm reaching billions of people a day.
You see the impact every single day on real people and your friends and your family, and that's just magical.
Hello, welcome to Women Techmakers, live on location at Google I/O. It's incredible to be here. We have a fabulous lineup of speakers. We've set up this session as a series of lightning talks. So we want to ignite and inspire with topics around search, of course, but also Google Glass, some product insights, AI, knowledge, and other topics. I've asked all of our speakers to tell personal stories as they walk through these topics, and we have a bit of a theme of past, present, and future. But before we start, I don't know if my slide thing is advancing, so I'm going to come over here. Hello. Sorry, guys. There. So this is the lineup. And before we start, I want to talk a little bit about why we started Women Techmakers. Last night we had a fabulous gathering of the women, a pre-gathering, the women who are here at I/O. And we might be in the minority, but we're fierce. And it was really fun, a good social experience, and we want to build community amongst women with our male colleagues. We also are working on visibility. And women are largely invisible in technology as part of our feeling. And so our goal is to increase visibility. Our industry is probably 10 or 20% technical women, sometimes a little higher. We want to get to 50%. We want to match the population. Products are just better when they're built by diverse teams. Companies are better. The world is better. And that's part of our goal. I wanted to give a shout out to real progress that's happening this year. Sheryl Sandberg, who's a fabulous colleague, Google alum now, leading Facebook with Mark, has really driven the national and international conversation up. We need to be talking about these things. I don't know if people are familiar with the Maker series. Maker.com, AOL, and PBS have launched this. It's the modern women's rights movement's history, documentaries, and really shining a light into actual fabulous stories, the backstories on women that you haven't really heard before. And you just saw a video clip, a montage of something we've done, which is called Makers at Google down here. Which you can get to on google.com/diversity/women. We really want people to know the stories of the women who build YouTube, the women who build Android, the women who build search. And so we've launched this series starting today. As part of celebrating what's going on in some momentum, we have a long way still to go, but we've come a long way and really upping the conversation. I just want to shout out to some of the giants we stand on the shoulders of. This is Catherine Switzer, first woman to run the Boston Marathon. officially. I encourage you to watch her story. The race director tried to rip her numbers off. It's on makers.com. And this is Elizabeth Cady Stanton, and she's delivering the Declaration of Sentiments in the mid-1800s at the first Women's Rights Convention, back when women weren't allowed to go to university and were not allowed to do many things. How many people in this room have ever heard of the Declaration of Sentiments? There's 1, 2. Looks like for people on live stream, we're probably at about 10%, which brings me to the point I want to make, again, about visibility and invisibility. We really have a problem with how visible technical women are. And so I want to jump into 2 things before we start. Sometimes you're lucky to, there's symptoms of a problem, and sometimes there's roots of a problem. And I stumbled across this when I met Gina Davis, the famous Academy Award-winning actress. Gina was watching TV with her children when they were young, and she just, as an actress, she could see that TV was biased. And she'd say in the industry, there's not enough women and girls on children's television. People would say, yeah, of course, there's plenty, like Dora, the Scooby-Doo girls, lots of people. But then she thought, no, there's not. Let's measure. You manage what you measure. So she measured it together with USC Annenberg. And the studies were showing, and they had grad students counting by hand, it's actually 3 to 1 across all of children's television, the corpus of children's television, of men and boys versus girls. And so the girls aren't equally represented. And you see amazing things that you wouldn't even notice. But how many women in the whole ocean in the film Nemo? How many monsters or Muppets were in Sesame Street who were girls until the 90s? That would be 0. Nemo, 1. So we're not accurately depicting the world, and we're skewing it. So one of the things we've been lucky to do, and also one more stat, the 80% stat, 80% of the jobs that were held by characters in the television our children watched were held by male characters. So we taught our kids that girls and women don't do STEM, which it just doesn't happen to be true, as we'll show in this session. And so we really need to get in here. We are now working with Gina on trying to automate some of this so that we could have a gender disparity measurement ability to look at our media. And I encourage everybody who has technical background, look at ways we could use technology to count bias so we can measure and see things. The last thing I'll point out before we start about things, one more example. This is so insidious, like our bias, that I was looking at a catalog recently, and this was a dresser for a boy and a dresser for a girl, and the colors are different. But really, the big difference to me that I saw because of being aware of Gina's work was that the boy got the microscope and the girl didn't. So as you now know this fact, you're going to notice it everywhere. And it's something we need to work on. And if we could use technology to help ourselves see it, we could get out of this historic bias that we inherited. The last thing I would say before we start is around becoming visible includes not only seeing the technical women who are here today, but also the historic women. I don't know how many people recognize some of the people on these slides. Yeah, I see a couple hands, but really probably these people are pretty unknown to you. Ada Lovelace is represented in the doodle. She's from the 1800s. She's actually the first person in world history to think of programming something. She's the founder of our industry. There's the women who were astronaut corps. Nobody knew about them. We know about the men. Some of the most decorated Americans, of course, are the astronauts from the Apollo and Mercury times. They were there. They just weren't allowed to fly. Grace Hopper. This is the Whirlwind Project at MIT. The Bletchley code crackers, the Enigma code crackers from World War II, more than half women, mathematicians. Hedy Lamarr. Hedy Lamarr helps you have your cell phone work. And up on the top, there's a wonderful thing that Singularity University launched last week, and I encourage all of us to help. It's a crowdsourced history idea. And so innovatingwomen.org, please go there, please help capture these stories. And last, I want to point to this picture down in the bottom, University of Pennsylvania, World War II. I want to bring Kathy Kleiman on stage. She's going to share an extraordinary story from history that I was lucky Brad Feldman alerted me to. He's here. Kathy.
Thank you so much, Megan. I'm thrilled to be here with all of you today. And I have an amazing story to share with you. But first, I have 2 questions. The first one is, does anybody here know who invented the first sort routine? It was Betty Holberton. Another question, who invented the first software application? That was Betty Holberton, too. We don't know about her because she was never written into formal computer history. In fact, her story was almost completely untold. for a very long time. I know because I found it. Can we go to the slide, please? Thank you. No, because I found it. When I was an undergraduate and a computer programmer, I felt very isolated. I didn't see women around me. I didn't see them in my classes. I didn't see them as faculty in my computer science classes. So I turned to history to see if I could find role models. And I found this picture. This is of the ENIAC, the first all-electronic digital computer. It was a secret project during World War II at the University of Pennsylvania. And when I found the pictures, the men were in the captions. That's J. Presper Eckert and John Mauchly on the left and right front. And they're the co-inventors of the ENIAC, very famous. But there were women in these pictures, and I wanted to know who they were, and they weren't in the captions. So I took the picture, and I went to a leading computer historian, and I asked her who they were. And she said, they're refrigerator ladies. I said, a refrigerator lady? She said, they're models posed in front of the machine to make it look good, like the Frigidaire models who used to open the new refrigerators with such a flourish. Well, they didn't look like models to me. These women look like they belong in this picture, and they look like they know exactly what they're doing. So I set out to find them, and I did. That's Jean Bartik in the far back, and Ruth Lichterman Teitelbaum in the front. They were two of the original ENIAC programmers, and I was thrilled to learn that all 6 of the original programmers were women. So now I'm going to take a pause. Thanks to the wonderful women Techmakers, I've been able to bring you a short video of the ENIAC programmers telling you a bit of their story themselves. It's part of oral histories I've collected over many years, and I'm thrilled to be able to share this with you.
Computer field. From the very beginning, you're going to be the first in a lot of things.
I've never since never been in as exciting an environment. We knew we were pushing back frontiers.
In February of 1946, 6 months after World War II had ended, America learned of a secret army project called ENIAC. It was the first all-electronic digital computer. Yet the tale of ENIAC's programming by a group of young women has been all but erased from computer history. During World War II, the US had assembled a crew of nearly 100 mathematically trained women whose official title was computer. Women who were computing complex ballistic trajectory equations by hand and using mechanical desktop calculators. In the spring of 1945, 6 were selected to figure out how to program the ENIAC machine. Fran Belis, Betty Jean Jennings, Ruth Lichterman, Kathleen McNulty, Betty Schneider, Marlon Westkoff.
We were computing ballistic tables on a hand calculator. We were computing, and we were computers.
There were logical diagrams of the ENIAC, and we were supposed to study them to figure out how to program it. The ENIAC was a son of a bitch to program.
ENIAC became a legend. Eckert and Mauchly became famous. However, the ENIAC programmer story, the story of these 6 women founders who created the first sort routine, first software application, and became the first teachers of modern programming, was never told. Their work dramatically altered computing in the 1940s and 1950s as they paved the path to modern computer science.
At that time, the emphasis was on the invention of the ENIAC. I mean, developing the mechanics, the hardware.
We were like fighter pilots. I mean, here was this great machine, but you couldn't just take any ordinary pilot and stick him into a fighter pilot and say, go to it now, man. I mean, that was not the way it was going to be.
I had a fantastic life. Everything I did was the beginning of something new.
I really loved working with those girls.
Aren't they amazing? And their work didn't stop with ENIAC. They became the first teachers of modern programming. They became the first modern professional programmers. And Betty and Jean went on to program Bionac and Univac, the first commercial computers, and they created innovative tools that changed the face of programming forever. Absolutely amazing. And in a very nice twist, Betty Holberton actually interviewed Grace Hopper to invite her down to Eckert Mauchly Computer Corporation, the first commercial modern computing company. And Grace, of course, accepted. So now, thank you. So now, today, I have an amazing announcement to make. After so many years of recording their oral histories, researching their accomplishments, and working so closely with the ENIAC programmers. I'm thrilled to tell you that, and I'm thrilled to announce here, that final funding has finally been put together so that I can produce a documentary and finish my book on the ENIAC programmers and share the story with all of you. This is happening because Megan Smith introduced me to two remarkable technical women of vision, Anne Wojcicki and Lucy Southworth Page. And they're providing wonderful support through their foundations, the Bryn Wojcicki Foundation and a donor-advised fund on behalf of Lucy Southworth Page. And I really want to applaud them because this is amazing. And thanks to this support, I will be in production this summer with the Paul Freeman Film Group, and we will be producing a documentary, and we'll have a book for you very, very shortly. I can't wait to share this story in its full form. And now I want to share just a personal story about how I learned firsthand what history and visibility can do to shape our viewpoints. 10 years ago, when my son was 5, he came over to me with a very confused look on his face. He had grown up with my work on the ENIAC programmers, and he had even met and actually played with 4 of the original 6 ENIAC programmers. And he looked upset, and he said, "Mom, I know that women can be computer programmers, but can men be programmers too?" I assured him that, of course, women and men could be programmers, and in fact, technology was better when we created it together. And when I left him 2 nights ago, he was programming. And so what I want to do and conclude is say stay tuned for more about the ENIAC programmers, and please join me in the quest to capture wonderful stories of women in technology so we don't lose any more. And on behalf of all of us, I want to thank you.
So now we're going to start into the lightning talks, and I have the honor of introducing Susan Wojcicki. Susan has been at Google since the start. She's actually our first landlord, and I hope she's going to tell you a little bit about that. But Susan is our Senior Vice President of Advertising, and she really runs all the products that make all of the money that allow us to do all the amazing things that we're able to do. She's an extraordinary executive and an extraordinary visionary strategic leader. One of my favorites, just the personal stories, my favorite experiences are, Susan is always like double and triple booked, and she adds a lot of value, so we get her everywhere. And often if you're in a meeting, and there's a lot of people debating ideas, and ideas are flowing around, but you can't really get moving, when Susan walks in the room, it just changes. Within 5 minutes, people are focused on a screen and kind of narrowing in on where we're going to go. She just knows how to lead. She knows how to see the future, and she's an extraordinary leader of Google and of our industry, and I welcome Susan Wojcicki to the stage.
So good evening, everyone. It's really great to see such a wonderful turnout for our talk here. And since this is a developer conference, I thought I would talk about a few key principles that we use when we're developing Google's products. And I've been involved for a long time in a lot of products, so I summarized this down to 2. But before I do that, I'm going to talk a little bit about my personal story. And since Megan talked about me being a landlord, I thought I would start there. And so when people ask me the question, well, how did you decide to join Google? I sometimes have to say, well, my story is kind of unusual. It's not really like everybody else's story. I actually lived with the company, Google, for 5 months. And, right, I don't think really anyone else can say that, except probably my husband. And so what happened was I was renting rooms in my house, and Sergey and Larry had just gotten funded for their company, and they were looking for space, and I was looking for renters. And we agreed on an amount, and they moved in. And at first I didn't really think that much about it, other than they were renters. But then, people would read about it, and then they would ask me questions, and I would say, oh yeah, I know them. They're actually renting in my garage. So I started using the products, and you have to remember there were a lot of big competitors out there that were much, much bigger than this little company of 3 people at the time. And so I started using the product, and it was pretty good. And I had this realization at one moment because the site actually went down. It was the servers were still running at Stanford. And it was at that moment that I couldn't reach Google. And that's when I really realized how important it had become to me in my life. And I realized the potential for the world. And that's when I decided I really wanted to join Google and be part of that future. So that's my story in terms of why I joined Google. So I joined, and I was there for one day. And Sergey comes up to me and says, I have a mission for us. It's to organize the world's information to make it universally accessible and useful. What do you think? And I said, well, you know, they're like, I was employee 16. So like, there are less than 20 of us here. And you guys all just graduated from college. So that's like a pretty ambitious goal right there. But that brings me to my first point, which is that do something important, think big, and have a big goal of how you can change the world. And I was really pleased to see that Larry talked about that this morning in his keynote, where he said that there's so many things that haven't been done yet, it's important to focus on the great things that haven't happened yet. And that's really a focus that we have in our development process. And a lot of times, doing big, ambitious things sounds really hard. In fact, they sound crazy, and they sound impossible. But when you break them down into parts, a lot of times you can realize they're actually doable. And doing really hard, crazy things also has the advantage that it's a lot less competitive, because there are fewer people who want to do crazy things like you. So let me give a few stories. So let me start with Street View. So we have the beautiful imagery that comes from the Bright Angel Trail in the Grand Canyon that we have been working on. In fact, here in the lobby, you can actually see the camera that has created it, and you can actually try on the backpack and walk around and see how we did it. And but when I first heard about Street View, it was just the idea, which is let's create a way to take pictures of all the streets in the whole world, right? And I'm like, okay. And then you think about it, and these ideas sound crazy at first, but then you start thinking, well, how would you do that? And you start thinking, well, you would have cars, and they would have cameras, or you could have people, and they could have cameras, and then you start talking, well, what kind of cameras? And then you find people who actually really want to do that, and then you're on your way to making it happen. So we just launched our 50th country with Street View, and 5 million miles of Street View imagery. So from a very simple idea, we have something that enables people to see imagery from all over the world, which is amazing. So going on to the next big idea, which we are still working on, which are driverless cars. Now, if you think about driverless cars and you hear about this idea, it also sounds like this giant idea. Is it really going to get done? Are we actually going to be able to do this? And if so, when? And so there are many, many benefits. Like, it's probably the most dangerous thing we all do, but yet we have to do it, which is drive. And you think about the benefits of saving lives and emissions, and really could make a difference in the world. So my goal is to have the people at Google do this before my kids start driving. So I have a personal OKR here. But it's just an example of a really big idea that doesn't sound possible that you can make have happen. So let me move on to the second big principle that we think about. Now, when I'm working with teams and they are telling me they're going to create some new product, or they have some idea and they want to staff it and they want to build it, I ask them, well, what is your insight? Like, tell me something why you're doing something new, why you've observed something in the world that's different, and what's your insight that's going to make this product be a big success? And I found that if they can answer that, the product's usually a success, and if they can't, then it's often time to go back to the drawing board. And I think about the insights as, because there's so much technology and the world that we live in is changing so much, if we go around and we look really, really carefully at how the world's changing, and we see new technology, sometimes we can see glimpses of how the world will change in the future. And if we can see that glimpse, then we can build around it, and we can plan for it, and we can build those next generation solutions. We can build that future. So I'm going to give a few examples, actually, of insights that have been really important to me in my product development and that have guided me. And again, a lot of times these are just one sentence, but they're powerful because it's a nugget that you can use to build your products. So I was working on Google Video, and as you can see, we have the YouTube logo here. When I was working on Google Video, we were working with studios who had great content, and we were working to bring this online. But at the same time, after we had just gotten it online and users were starting to be able to see it, we had this other video that became very, very popular. In fact, it became, the numbers were significantly larger than what we were seeing from this studio and the studio deal we had done. And it made me realize the power of user-generated content. So do you guys want to see that video? Yes? All right, let me show you a few, just like 15 seconds of it. But it was this video that really gave me that insight and that inspiration. What I love about the video is that the roommate is doing his homework in the background the entire time and doesn't notice. But this was an insight. I realized, wow, this user-generated content, it can be really, really powerful. And today we all know that because that's what the world has become, user-generated content. It has its place, it's very valuable. There's also all kinds of other content that's produced professionally that's really, really important to the ecosystem too. But it was that video that really gave me the confidence in thinking that we should acquire YouTube. And I was a big advocate of it, and Google spent $1.65 billion. So sometimes you have one little insight, and from that little insight, you make a really big decision. So I want to talk about another insight that's near and dear to my heart, which is ads. I'm responsible for Google's ads business. Now, we created an ad system when Google had not very many people at the company. I would say probably like 30 people at the company. And we didn't really have enough people even to build a search engine, let alone to try to build an ad system where nobody knew anything about advertising, nothing. Like none of us had ever worked in it. But we had an insight. And that insight is something that I still use today when I think about the ad products that we build. And the insight's very basic, but it's ads are information. Now, if you think about ads being information, and you think about them just being commercial information, then the ads need to be relevant, and the ads need to be useful. The ads need to be shown to the right person at the right time, just like we think about that for our search results. And so that meant we had to build our own ad system. That meant that if you typed in flowers, you had to see ads about flowers. That if you typed in the name of any book, you had to see that all the ads had to be about the book, not just for a bookstore, but for that actual book. And so that's a principle that we use that caused us to build an ad system. And if I think about things today, sometimes I'll get questions. Like when we first went into display, people would ask me, how do you feel about image ads? How do you feel about video ads? Do you think an image ad could not be a good ad? And you think about that. Well, an image is information. Our image is useful to you. Yes, then an image ad can be useful provided it's served at the right ad at the right time to the right user. All of it at the end of the day is about serving the right ad and making it useful. So that's an insight that we've used across our ad business from beginning till present. And just going forward, moving really quickly to the present, if you look at today and you say, well, what do you see about today? What are like things that you're focused on? I would say we have to be thinking a lot more about location. We have all these phones. The phones know where we are. How do we make all the services that we have super relevant to us? So you think about all of you having traveled, probably come from all different places, and staying in hotels and looking for places to eat. Now, how many of you have actually gotten some kind of offer related to where you are right now that would be useful to you? I'm like looking, but I see a few people. They're like the brave souls who or the people who have special technology or have special insights. But it's something that doesn't really happen yet, but there's no reason it shouldn't and couldn't. We should all be getting useful information based on where we are right now. And the reason we haven't is just because those systems haven't been built out yet. And so it's just an example of an insight in the way we should think about things in the future. So just to sum up, those are my 2 insights. That's how we think about building. We think about doing things that are really important, things that haven't been done yet, things that will be used by billions of people, and to think about insights and what the future will look like, get an insight into that future, and then build for that future. And by building for it, that will become the future. So I'm very excited about the future of technology and how it's changing our world. I think there's so many opportunities for us and for all of you, and I'm looking forward to that future. And now I'd like to invite Anna Patterson to come up on stage. Anna Patterson has worked on some of the biggest, most ambitious projects I've seen at Google, and she's going to tell you a little bit about them. Anna is Vice President of Engineering and Artificial Intelligence. What an amazing role and opportunity. So let's please welcome Anna onto the stage. Thank you.
So I'm here to tell a little bit of hacker stories from the trench, and I think with a main theme of perseverance. I saw that the ENIAC programmers, how they got a circuit diagram in order to program. My first programming job out of school was for the F-15E, and we would test our software the best you can on something that wasn't flying. And then, we'd invariably need to put in patches. And just like the ENIAC, you had to toggle in the program. So it was very scary, since people's lives were depending on it. But also, I was thinking about how source control has evolved. Of course, my first programs in high school were on punch cards. But at home, I was really fortunate that my dad brought home a Commodore PET computer, and he encouraged us to experiment and write a program on it. And I wrote a really, really horrible, terrible video game. And it only had 8K of memory, so I stored the program state like in the corners, so they were like flashing weirdly. And I guess it was a standard trick. I found out much later. But I was from the suburbs of St. Louis, so I wasn't really part of a burgeoning hacker community. I eventually got my PhD in computer science at University of Illinois Champaign, and then I became a research faculty member for John McCarthy, the founder of AI. And I see several people here who know me really well, and so you'll appreciate when I say that John McCarthy made me do something, how hard that must have been. So he made me look into this area called phenomenal data mining, where you're given facts and relations, and you're given a big data set. Big was very small in those days. And then when you learn new correlations, you can explain these new correlations in terms of underlying phenomena. So that's where it got its name, and that technique is still in use. But everybody was leaving the department to start companies, so we were pretty much like the last ones out when the lights were turning off. And I co-founded in 1998 a web mining company. Because the web was so big at 5 million pages, we thought, how are people going to be able to get around this thing? And so we had an idea to make an automatic taxonomy and kind of lead people to what questions were answerable on the web and what ones weren't. Because in those days, trust me, there weren't really recipes on the web, but the taxonomy around Linux was deep. So we got angel funded to do this just in time for the .com crash. And so I tried to figure out what my other passion was, and I said, mobile is just about to take off. So I moved into the mobile area in 1999, just in time for the telco crash. So after killing 2 industries, I was actually, had a 1-year-old, and I was 4 months pregnant. And of course, I was unemployed, and I was actually living in Pavni's guest room, who's in the front row. And so the doctor said, you need to be on bed rest. And I said, have you ever heard of programming? And he hadn't. And I said, it's a lot like bed rest. So I volunteered at the Internet Archive, and they have snapshots of the web over time. So as such, especially in 2001, it was much bigger than the web. It had 30 billion web pages, and the live web at the time maybe had 5 billion. So I did a history-based search engine that launched at like 12 billion pages, and you could look at how terms change over time. So you could dial back to 1997 and search for a term like Clinton, and you'd see all these co-occurring terms in a graph and how they changed over time, and it was very presidential. Dialing it up to 1999, it wasn't quite as presidential. And then moving forward to today, everything is about Hillary Clinton if you search for Clinton when you look at the popularity of the things on the web. So it was a really interesting project, and I was doing it as a volunteer, and 4 days after it launched, various companies wanted to talk about acquiring it. So I go from volunteer, stay-at-home mom to the world of corp dev. So that was really fun. So that's how I wound up at Google. And at Google, I really wanted to unlock some global and local information. One of our examples was about these small towns in Germany with their local Oktoberfests and how that information was really important to them. And we weren't quite big enough to get everything to everyone. And so at Google, we evolve our systems. So just when one system launches, we would start a new one. So when one such system just launched, I came up with the idea for TerraGoogle. And speaking of thinking big, probably 95% of people said, why would we ever need a search system for a trillion pages? And of course, the founders were like, is that all? So at the time, it was very cost efficient. When it launched, it was about 50 times cheaper than our mainline index. And at the same time, some of my web ranking team went off and they shipped one of our early deep learning projects, which was around ads broadening. Like once you bid on one keyword, what other keywords do you might be interesting? So after having my fourth child, I did what everybody does when they have 4 kids and they're on maternity leave. I decided to start a company. So I started a company, Cool. And we really wanted to bring like a really high-res, rich experience to people with high bandwidth and a really low bandwidth experience to people who had like feature phones. And so what we did around the low bandwidth experience is we summarized things so that a fact that appeared on tons of web pages was on top in kind of paragraph format with a bunch of references down to much rarer facts had much fewer references. So after Cool, I returned to Google, where I became one of the first 100 engineers at Android, because this time I was pretty sure the mobile revolution was going to happen. But it wasn't, a sure thing. I mean, at that time, Android had sold, 40 million phones. And of course, today it was announced that Android now has 900 million. I was part of the team that helped launch Google Play on Play tablets. And very recently, like 2 weeks ago, we shipped a native search architecture onto the phone to index all the local data so that when you're offline, you can have access to it and some data never leaves your phone. So a lot of people say, wait, Google's so good at search, why didn't you just compile the thing and put it on the phone? Well, the phone is kind of like my early Commodore PET computer, not quite as bad, but compared to a data center, it is. And each of the programs can only have 20 meg resident in memory, and the executable is 500 meg as hard constraints. So trust me when I say that Google search system, its executable is bigger than 500 meg. So when we look at this system, because the success of Android is a compute cluster, it's actually over 500 exahertz of computing power, which is way more powerful than the human brain. So last autumn, I moved over to our new AI area, where recently Ray Kurzweil joined us, and he says that the AIs that humans create are going to leave the Earth at light speed and populate the universe. So we're not just working on the most important project on planet Earth, but in the universe. So I do want to encourage the tech makers out there, women and men, to really reach for the stars and use technology to help shape the world. You know, technology is a very powerful platform in order to help people and enable change. Thank you. Now I want to introduce Johanna Wright. She's the lead product manager of search for many years, launching such innovations as universal search, instant, and the knowledge graph. And now she's leading up search in Android, including Google Now, voice search, and speech.
Let's step back to January 2003. At this point in time, I'm living in my father-in-law's house. He's put a nice curtain up for my section of the living room where my husband and I share an air mattress. The sun streams in, 6 a.m. We wake up every morning because of the unbearable Orange County heat. The air mattress is popped, and I'm unemployed. Just 6 months earlier, I was a young tech exec in New York, first during the dot-com boom and then bust. But my company that I worked at had finally shut its doors, and my husband and I decided to get on our bicycles and ride across the country to lovely, sunny LA. Riding across the country with your new husband is a lot of fun. Showing up in LA, a new city with no job, not so much fun. Then the rejection letters from business school started pouring in. And it's January, and there's only one business school I haven't heard back from, but I'm not feeling too optimistic because they're supposed to interview all of their candidates, and they're going to mail out their verdict 2 days later, and they still haven't interviewed me. But then I got an email from UCLA that said, "We want to interview you." And since my confidence had been shot, my response was, "You do?" I was fortunate enough to get to go to UCLA for business school, and then I got a job at Google. And today I'm going to talk about my career starting out at Google and what it was like to be a product manager at Google, and give some bits of advice about product management. But my first piece of career advice is that your career is not going to be linear. Expect to be disrupted. This is a disruptive industry, and you too may someday be unemployed on your father-in-law's couch. What's really going to matter is the energy and the tenacity with which you pick yourself up and take on your next adventure. Okay, so let's jump into Google. I was hired to be a product manager working in search. My boss gave me two options of jobs. One was something called universal search. Universal search was a project where we took all the content from our different backends, maps, videos, images, and we put them in the main search results pane. The other option that she gave me was to do something called premium content search. This is where we searched all the content behind paywalls and put it in the search results. Both of these things seem pretty interesting. And I was so new to Google, I didn't have any context or judgment to make a decision. Fortunately for me, I'd gone to the same business school as Susan Wojcicki, my fellow panelist, and so I asked her for some advice. Susan looked at me like I had two heads. What? Of course you should do universal search. That's our business, Johanna. So this leads to another piece of career wisdom. What does a good opportunity look like? Well, a good opportunity looks like something that's strategic. If you're doing something that's in line with the company's mission and has not been done before, well, then it's very likely to be a good opportunity. Okay, so let me jump into universal search. This was 2005 at Google. Google was growing like crazy. It was very chaotic. And it's kind of hard to know, for me, it was hard to know how projects got assigned, what you were working on. And I got paired up with an infrastructure team while I was working on universal search. This was a great team, but a team that was very focused on building infrastructure. And they didn't want to build any features. And I was a product manager, and I was being judged on the features that I launched. And so it was pretty stressful because I wasn't delivering anything. And so what I ended up doing was creating a set of mocks, a series of mocks of what universal search could look like. And then I created a little PowerPoint deck, and I walked around Google, and I introduced myself to anyone who looked like they might want to be a features tech lead to see if they wanted to join my project. And I was fortunate enough to meet a person named David Bailey who wanted to join on and lead the features side of the effort. And then the project really started to get legs. And so here's my beginning of my product management specific advice. And that is to paint a vision. Once you paint a vision and you share your vision, people will follow. It'll be a lot easier to follow once you have a vision. Okay, so David and I started. There was a big mountain in front of us. We didn't really know what to do. This project had failed a number of times before. We didn't really know why it had failed. And I had this idea that we should do a user study. I was trying to figure out what to do. I said, well, let's just do a user study. So we pulled together a prototype to do our user study. And once we had this prototype, the people around us in Google started to be able to imagine that this product might come to life and that something might happen. And so this brings me to my second piece of product management advice, which is that if you don't really know what to do, you should just do something. Do something to move the ball forward. I was very fortunate, though, that a user study was what we decided to do because people loved it. And it was so awesome. We learned that the project and the product had legs. So I remember sitting in the labs, and it was in the spring of 2006 for our user study. And one of the searches we asked people to do was bury bonds. Now, this was a long time ago. This was the dark ages. YouTube was just starting out. But there was a home video that someone had uploaded of Barry Bonds tying Babe Ruth's home run record. And the participant in our study, she clicked on the video. She watched the ball sail out into the field, and she had this big smile on her face. It wasn't unnatural at all that she saw this video in the search results. So we knew the project had legs. And it was just a great moment. So my final and most important piece of product management advice is to listen to your users. And even more importantly, use your products yourself. Just this weekend, when I was using Android search, I noticed that speech recognition is slow, like maybe 1 in 7 times. I don't know why, but I'm really glad that we're investing in speed. Then I also had some magical experiences with Google Now. So I was invited to go to a birthday party in Burlingame, and Google Now reminded me about the party. And it even told me that Burlingame was 30 minutes from my house, which I didn't know, and it was super helpful. The more you use your products, the easier it is to make decisions and to have an intuitive feel for what you should be doing. So I'll summarize my product management advice. 1, paint a vision. 2, when you don't know what to do, just make mini milestones. Roll that ball forward. And 3, use your products. Since this is a Women's Techmakers event, I thought I'd close with my very own lean-in story. So back when all this universal search stuff was going on, I ended up getting pregnant. And when I was 8 months pregnant, my boss, Marissa Meyer, suggested that I lead a team of senior engineers to come up with a search strategy for the next year. Now, the search strategy, the normal process was to set this meeting in mid-November, but my baby was supposed to be born at the end of October. And so they were like, hey, no problem, we'll just move the date up. Didn't give me very much time to prepare. And my baby was something that you call transverse, so he's lying on his side, and I had to have a C-section. So they moved the date up. I moved my C-section to the very last possible date. We met in the middle. And on Wednesday, I gave the strategy presentation. On Thursday, I had my baby. Now, this might be horrifying to some of you, but to me, it was invigorating. And it set me up to have a leadership role in search when I returned from my leave. And the point I want you to take away is not that you need to sacrifice your family for your career. I feel fortunate enough that I haven't had to do that. You see, there was no question in my mind that given that opportunity, I would want to give that presentation. And it was really huge that my manager believed in me. So the takeaway that I'd like us to take is that as managers, we shouldn't assume people's abilities or desires. We should ask. As managers, it's our job to enable greatness in our teams. So now I'm so excited to introduce Diane Greene. Diane Greene is the latest member of Google's board of directors. She's also a board member for Intuit and MIT. Diane is probably most well known for founding VMware. VMware went on to define the visualization industry. Diane was the CEO of VMware from 1998 to 2008. She took the company to $2 billion in revenue, and she took the company public. When I heard that I got to be on the same panel as Diane Greene, I was flabbergasted and so excited. And despite how intimidating her resume sounds, Diane Greene is actually quite approachable. I heard her speak last year at a Google event, and I went up and introduced myself afterwards, and she was very friendly and nice. So if you get the opportunity afterwards, I would encourage you to shake her hand. Diane is also a national champion sailor. And with that, Diane.
Thank you for that introduction. She went further than I suggested she go, but you know, how did I manage to do these things? What I thought I would do is take you on a whirlwind tour of my life and try and highlight where I thought I learned valuable things. And I grew up sailing, racing sailboats. And when you race a boat, you have to build a team, and you have to get your team all aligned on a single goal, which is to win the race. And then you need your strategy to win the race. You know, you have to understand what the wind's doing, understand what the currents are doing, and you know, pay attention to your competitors. And if your competitors surprise you or you get a wind shift, you have to immediately react and handle that and continue winning the race. And the last thing is the engineering around sailing. You know, you have to prepare your boat. It has to be ready to go fast, and you have to tune it while on the race course to keep going fast. And I think that's what led me to train. I trained as a mechanical engineer and then a naval architect. I came out to the Bay Area, to San Francisco for my first job. And the first thing I was given to do was analyze some mooring for an offshore oil platform that was used for firefighting. And there was a big 4chan program that looked like it was the way to model this, and so that's when I learned how to program. And I found it, it was just this incredibly powerful tool, software. You could do anything with it. Got pretty excited about it. Was not very excited about sitting inside behind a desk. I really came to the Bay Area for the windsurfing. And so I quit that job and I moved to Hawaii, where I think I had perhaps one of my favorite periods of my life. I lived sort of in a commune where we were exploring. Windsurfing was sort of an early microcosm of the tech industry. I mean, we were just inventing all kinds of things. And new sails, high aspect sails, new shapes of boards, new materials, and all we did was build and test this equipment every day. It was really tremendous, and from there I went and ran engineering for Windsurfing International. That was the company that had the patent on the windsurfer, which also taught me how abused patents can be, because they tried to control a very rapidly expanding industry with their patents. I left that. Well, all this time I continued to study software. I went back up to the Bay Area and enrolled in a graduate program in computer science at UC Berkeley. Berkeley was a pretty happening place at that point. We had the grad students had a lab full of brand new Sun workstations that were based on this Unix, new open, relatively new open operating system. Richard Stallman, who wrote the GPL license, was hanging out there. I got to see the first graphical user interface, and it was just very exciting, and I knew it's what I wanted to keep doing. I did still yearn for adventure. I've always really loved adventure. So I took a brief interlude and went to use my computer skills to be the computer expert on a marine archaeology expedition in Saipan, where we excavated a Spanish galleon and found gold. And then I came back to the Bay Area and went to work at a succession of companies in the tech industry. The first one was Sybase, where I really got hit over the head with the value of having engineers across companies work together. I made friends with an engineer at Sun. It turned out he was a windsurfer, and we spent a few months windsurfing and writing software, and were able to get sort of an order of magnitude performance increase in the Sybase system running on Sun. And I really used that when I built VMware. All three companies were quite an education in how important it is to embrace change and always go forward, invest in the future. Sybase didn't want to rework their system to support symmetric multiprocessing, and that's sort of why Oracle eclipsed them. I went to work at Tandem that had the world's best database management system, but it ran on proprietary hardware and proprietary operating system, and it was too hard to see the business model for moving to commodity open systems, and they sort of sailed into oblivion, getting bought by Compaq and then by HP. And then I went to work for SGI, which was a pretty aggressive tech company at that point in time, and worked on interactive television, which was a really exciting project. But again, as you know, the internet was happening, and it was starting at SGI, but instead the founder of SGI, Jim Clark, left and founded Netscape, and a number of us left and started companies, and that's when I finally just decided to stick with startups. And so I did 2 successive smaller startups. The first one, they both had great visions. I would say they maybe executed too early. Nice financial outcomes. The first one was streaming video and over the internet, low bandwidth, because there wasn't much bandwidth. And the second was internet ad serving, interestingly enough. At that point, I took a little time off and decided to found VMware, which was based on some work my husband was doing at Stanford around virtualization. And you know, there's a few things I can kind of relate to what we did at VMware to what I had already learned. For instance, Sun Microsystems, you know, introduced these workstations. People loved these workstations and then brought their servers into the companies. And at VMware, we used the same strategy. We had a workstation software. People loved our workstation software. And then when we came out with the server product, we're pretty quick to adopt it. We did amazing. Our engineers worked with the hardware vendors. They worked with the chip vendors. They worked with the storage vendors. And then we worked with all of those vendors to take it to market. And I'm just a huge believer in collaboration in the industry. And it was really effective for VMware, but it was always hard to convince other companies to trust us and partner with us. But I think we always won jointly together. And then the last thing was just sort of how to adapt, how to embrace change. You know, my job changed considerably from 0 to, you know, the sort of 6,000, 7,000 people the company was when I left. And it's just sort of recognizing, okay, this isn't working, and constantly sectioning out parts of my job that I just didn't have time for anymore, and hiring someone to do those things. VMware was just a totally fun adventure, building it with all those people and seeing the impact that it had. And what I would say is it's not so important how there's just sort of an infinite number of ways to do things. But when you see something that you're very interested in, that you think it can have some real impact, the thing that's important is to codify that vision, see that vision, enjoy the adventure of building that vision. And if you do enjoy it, it makes it fairly easy to be fearless about it. So now we're going to shift, and we're going to hear an amazing talk by a hardware lead at Google. She has, Jean Wang has a PhD in electrical engineering in photonics. She worked in the optical communications and then came to Google. She's the hardware lead on Google Glass. As a board member, I have Google Glass. I love it. It's so much more natural than a phone. And now you get to hear about how she did this. Thank you.
Hi, everybody. Smile. So I'm very happy to be here with you today. I'd like to share with you my glass journey. It's a 3-part story that spans across multiple domains. And while it is yet unfinished, I hope you share my enthusiasm for what is yet to come. Before diving in, I'd actually like to float this number briefly and plant it in your minds. It has significance to me and the story. And in the meantime, please feel free to question the number base that I'm using. So Glass, like many ideas, started as a blank canvas. As part of the initial team, we came into the project largely inexperienced in the field of head-mounted displays. Instead, we had the ability to divide and conquer through our ability to learn and adapt. While some of us focused on optics, like myself, others worked on cameras, sensor systems, electronics. And so we also came in with the fundamental belief that technology had ripened to the point where we could make a significant impact and create something of significant use. And that has led us into the discovery phase, to find out just what it was that could be done, to basically minimize the barrier to information access and to make us connect with each other in terms of accessing our social sphere. As part of the discovery process, we looked at existing products in the mobile space and wanted to really understand where it was that we can make an impact in terms of form factor. For example, whether it was bulky and had to fit into our pocket or carry around a bag for it. Ease of access, whether we had to pull it out of our pocket or a bag to actually engage with it. And also ease of use, whether we were blocked when we were using the device, or whether we could look straight ahead and talk with people and not be distracted. So to push on these pain points, we did a number of technical experiments. Here's a helmet-mounted display that did not allow us to be hands-free or wires-free. And on the bottom, you can see here is an early optical experiment to help us understand the technical complexities in terms of how optics sizes actually impact the performance and the image quality. So with these considerations in mind, we dived into selecting components that we can use and make a viable solution. So in the vast array of options, we looked at what it was we could just reuse and customize, or was there something that we had to invent for ourselves? So we played around with a bunch of pico projectors and projectors. We looked at optic components such as lenses and prisms, as well as interface devices, touchpads, microphones, speakers. And underpinning the whole system was electrical components and board design. So in this huge selection of choices and huge array of options, how do we down select? And so we filtered using 2 key criteria. One was power consumption, and the second was weight. So these 2 are basically factors in enabling us to first wear a system all day, and second, actually allow us to want to wear a system all day. And so we headed into the second phase of prototyping. Here are 6 example generations, oops, little slide mishap, of glass prototypes. Starting at the very top left, we took the lowest hanging fruit of simply putting a mobile phone to the side of the head. And a pico projector shining directly into the eye to provide the image. And so this was a bit bulky, as you can imagine. It came in at 167 grams. And we wisely decided that we could lighten the load by taking the mechanicals off the phone. And that's our second proto, shown right up there in the middle top. And so as you can see, over time, we shifted from using off-the-shelf components, such as safety shields and frames, into 3D printing our own frame. and that's shown here in the third. And you can also see that we migrated into making our own optical design and architecture, which is something we carry through today. And as you gradually evolve to the very end, you see that more and more we use customized components, and we look at making our own plastics and metals to get to where we are today, which is essentially the essence of what glass needs to be. This provides the core and provides a very minimalistic system that allows us to run around and be happy when we're playing with the system. And in addition to prototyping with the hardware, glass derives its use from an easy-to-follow UI. And this is by definition not necessarily easy to make. Along the way, we experimented with a number of different interaction concepts. For example, head gestures. And that recent SNL skit was not too far from a previous truth, if you've seen it. Also, we experimented with porting the keyboard functionality to the touchpad. We found that it was a bit too complex, even when running in a predictive word mode. We also tuned the number of lines of text, the font, the size, to basically optimize for readability. So through all of these things, we found that minimalizing and stripping down to the very core allowed for the best use case and experience. We also found that minor head tilts and voice commands allowed us for hands-free experience, which is very important when we're busy dancing or riding that roller coaster. On the flip side, having the touchpad and the camera button allowed us for more quiet modes of interaction. So with hardware and software solutions converging into a viable state, the team naturally turns to the question of production. It is possible to manually tweak and baby one device to get it to be close to ideal in terms of cosmetics and functionality. However, we like to share glass more broadly. And so that to us quickly turns into the question of scale. How do we build not 1, 1,000, 100,000, but upward towards a Google of devices? Layering and automation is key to this. And that means that not only do we have to build glass itself, but we have to build the infrastructure that builds glass. This floor space, the equipment, the whole kit and caboodle. And to add a bit more complexity, we'd like to honor individuality and human preferences. And that to us has meant color options. And that leads to color complexity. How do we make sure that on the device itself, part to part, the colors match? And how do we make sure that between devices, the colors match? So production requires the solutions to all of these questions and beyond. Through these three phases of discovery, prototyping, and production, I have found that glass is both an innovation and a reinvention. By integrating highly compact and new components, we've been able to extend far beyond in the field of head-mounted displays, beyond the last several decades of individualized movie players, game consoles, and aircraft systems. On the other hand, I think that glass is a way in which we can examine and develop new fields that we can push beyond and learn to be better connected to each other, as well as share perspective and have access to information. And all of this will allow us to better empathize as people and synthesize. So coming back to that number at the very beginning, it's been exactly, as of today, 1,111 days since I joined. And this is a picture I would not be able to take without glass. I am paragliding over Coronet Peak in New Zealand. And just by looking at it, I can recall what it was like to soar with the birds and to take in the beauty of the landscape. I've often been asked what the aha moments have been in the project thus far. And while I have a few, I'm more excited about what is yet to come. There is a first tier, for example, barcode, QR code scans, where we can get just-in-time reviews of movies, books, that menu trace we're just about to take, but we're not quite sure yet. Then there's also never getting lost and not bumping into things while you're looking at directions. And then there's a whole nother level. Recently, one of my colleagues exchanged his wedding vows while wearing the device. And I get goosebumps when I imagine him reliving that when he is old and gray and seeing the reflection of a future from his wife's eyes. And then there's also a physics instructor who recently toured CERN with the device. And he did a hangout back to his classroom in Michigan. And he was riding his bike down the tunnel of a Large Hadron Collider, showing his classroom just how cool it was, while taking live questions on the spot. Then there's also another example where glass can mean life or death. That it can help you translate to a medical doctor in a foreign country that you're allergic to penicillin. So through this process, I think that there's just so much potential in what is yet to come. That in pushing towards a new perspective on information sharing and perspective sharing, we've come upon a new environment and what glass can engender. And when I have time to pause and think about how far we've come, I feel privileged to be part of such a dynamic team. Together, we're striving to bring forward this new perspective. And I count you as developers as part of this growing group. There's just so much potential and positive impact in keeping in the moment, where information is just at your fingertips and knowledge is a twinkle in your eye. And with that, I look forward to your aha moments. And we are back to discovery. Thanks, everyone. I'd like to hand it back to Megan, one of my colleagues at Google X, where she is spearheading an idea for Solve for X to get us to more moonshots.
Thank you, Jean. And first off, thank you to all of our amazing lightning speakers. You guys were incredible. And also to Stephanie and Phoebe and Mimi and Sinead and Tara and Judith, who helped us put all this together with the amazing I/O team. Just quickly, Larry talked about thinking big. We've been talking about the idea of moonshots, going 10x instead of 1x. And so my colleague Astra and I have launched this site and this sort of goal to have the meme of moonshot thinking be something that more of us do. So Solve for X is this idea of there's a big problem in the world. There's some kind of crazy technology that is there. It feels like science fiction, or there's a reuse of something old that we just might be able to use as a radical solution to solve big problems in the world, be they self-driving cars or poverty or water or just more fun for everybody. And the main thing about this is that it's on the web, it's open. And so there's lots of proposals already up, and we've partnered with X Prize and TED and Arizona State University, Singularity, this great set of movies from GE Focus Forward about moonshots that people are taking. And so we're just trying to get the conversation going and really celebrate people who are starting or who are in process of moonshot, because we always celebrate the people who made it. But we really want to get more about collaborating and teamwork. Bill Clinton calls the 21st century the century of creative collaboration. And really the web and all the things we already know about, we already feel that. So that's what Solve for X is about. And along those lines, there's an idea that we have as part of it. My clicker's not working. About your X. Like X is a problem in the world or something you're passionate about. So I was really lucky as a student to get to take acoustics at MIT from Professor Bose, as in Bose speakers. He was an extraordinary professor. And at one point during our classes, he paused and he went into a lecture about life. And one of the key things that he said is, you guys are really talented, you're doing great things, you're going for it. The key thing now for you is figure out what are you passionate about? In some ways, what's your X? What do you care about? What do you want to work on? Because if you find that, you're going to be unstoppable and you will do extraordinary things to help people and make things great in the world. And I think that the women who we've heard from have found their X. And I hope that everybody will be thinking that way. I welcome to stay. Afterwards, I think Susan has to catch a plane, but everybody else is here. There's a bunch of great websites up, like the makers.com site. And in fact, today I heard somebody just told me that Susan's story is up on the homepage of AOL. So she's one of the makers, and she's there. And again, we've launched Google Makers at Google. And we hope that other companies and other organizations will start telling the stories, which leads me back to visibility. And let's make people visible. Help us do it. And thank you so much for being here.